Lesson 104, Abstract Rational Expressions. In the previous lesson, we talked about how to find the common denominator and multiply that common denominator as a whole number by each fraction in an expression that uses fractions, so that you can factor out and divide such that you can then use whole terms instead of fractions to complete your evaluation of the expression or the equation. We're going to continue to do that, but it's going to become even more abstract because we're going to be dealing with primarily with just variables. There won't be a whole lot of coefficients that you can actually calculate or do any real math to. It'll simply be an algebraic logic problem that you've got to move around and configure to solve for a specific variable. So let me show you what I'm talking about, because I'm pretty sure that all of that sounded pretty complex and it might have been hard to follow. It's easier to understand when you can just see it. So 104.1, let's just jump on into our examples here. We are going to find m. What that means is we are going to solve for m. So our final answer should be m equals something. That's what we're going to do, and that is what these abstract rational equations are all about. It will specify which variable it wants you to solve for, and that's the one you're going to focus on. Okay, so let's begin. We have 1 over x plus b over m equals c, and this is a relatively simple one. At first glance, you look at that and you go, no. But all we have to do is find our common denominator, which in this case is going to be mx, and then multiply each term by mx over 1. That's all we're going to do. So let's do that now. You can write along with me as we go, and that'll make it a little bit easier. Take very good notes, because if you don't take good notes, you are going to get lost. And we're going to write this c over 1 because it is not a fraction, so we need to make it a fraction. And to make a whole number or a whole variable a fraction, you just put it over 1. We already know this. Now we can cancel or factor out those common factors that are in the numerator and the denominator. Basically what we're doing is we are reducing these fractions before we multiply them to save ourselves some time in the back end. So we can get rid of x here, we can get rid of m here, and we can't get rid of anything here because we just have 1s in the denominators. So now we can go ahead and solve these. M over 1 is just m. Let me write this up here a little bit because I might need more room. M plus xb over 1 is just xb, and this is just mxc. Okay. Now we need to get all the m's on one side because we need to find what m equals. So we need to isolate the m. So let's just subtract the m from this side. That's going to be easiest. That cancels. So we're left with xb equals mxc minus m. Now we can factor out m since we've already got them all on the same side. So xb equals m times xc, and remember there's a invisible 1 in front of all your variables that are by themselves, so it's going to be xc minus 1. Okay? Now that we have two factors, m and this xc minus 1, we can divide both sides by xc minus 1. That allows us to cancel out the xc minus 1. And now we know that xb over xc minus 1 is what m equals. And that is our answer. All right. Let's move on to 104.2. If you need to pause, do so. Make sure you get your notes. Let's do 104.2. And on this one, I want you to find B. That is what we're looking for. And we have A over B plus C over D equals X. All right, so pause and write the next line, and then press play and see if you got the next line correct. All right, I'm assuming you paused. All right, your next line should look like this. All right, if you did not get that, go back, pause, go back and look at it and see where you messed up. We're going to cancel out now. So we have a B on the first one, we have a D on the second term, and nothing on the third term to cancel. So we can go ahead and write the next stage, which is DA plus BC equals BDX. Now we want the B's all on the same side, so let's subtract BC from both sides. We can factor out B. We can divide both sides. We can factor out. And then we are left with dA over dx minus c equals b. That is what we should have. If you have that, good job. All right, I would like for you to work this next one all by yourself. This is 104.3. You should have the hang of this now. We are going to find x. All right, and our problem is A over B minus C equals D over X. Right, so I would like for you to pause the video and work this problem out, and then press play once you've completed it and see if we have the same answer. So go ahead and press pause. I'm going to give you a minute. And then through the magic of video, I'm going to make the answer magically appear. And voila. Here is the answer down here. X equals BD over A minus BC. If that is what you got, then congratulations. You are understanding how to do this. If this is not what you got, then pause the video and look at what I have here in the steps and see where you went wrong. I'm going to clear the page and we're going to do one more and we'll do it together just to make sure we understand what's going on. Final one, 104.4. And we are going to find x again. And this is the problem. All right, and our common denominator is xn. So everything gets multiplied by xn over 1. And we turn y into y over 1. Remember, we can do this because of our rule that whatever you do to one side or to one term, if you do it to all the other terms, then the value of the equation remains constant. So that is what we are doing here. Right, now we can factor out or cancel the variables that are in both the numerator and denominator. So in the first one we have an x, nothing in the second. In the third we have an n, and in the fourth we have nothing. So now we can rewrite. Okay, so we had NA, XNY, XM, and XNK. And everything is over the denominator of 1, which means they're all whole numbers, so we can just write them as they are without fraction form. Now we are going to solve for x. And in order to solve for x, we have got to move some things around. So we are going to move x and y and xm to this side. Mostly because we don't want a negative. It'll just make it a little bit easier to do the math. So let's add x and y and subtract xm from both sides. These cancel. We can rewrite that as NA equals XNK plus XNY minus XM. And now we can factor out x. Right? Now we can divide both sides by that second factor. Now we can cancel this factor from both sides, or from the top and bottom, not necessarily both sides. And x is equal to NA over NK plus NY minus M. All right, that was a long one. And if you followed that well and were able to see the steps, congratulations. You are going to master this. If you're struggling with this whole concept of factoring the entire denominator instead of finding the least common multiple, then text me or contact me and I will walk you through it again. We'll give you some more practice problems. But it's the same thing as finding the least common multiple. It's just that you don't have coefficients or whole numbers that you can multiply. You have to take the entire denominator and multiply it times the entire fraction, or you're not going to be able to factor out and come to grips with whole terms. So, if you have any questions, like I said, contact me. And that is all I have for lesson 104. I will see you in lesson 105.